Hello, my name is Franz Joseph P. of Sena, and I'm here to present to you our group project proposal to implement face detection in Delsid to improve security in our campus, written and worked by me and all the couple members that helped me. So, moving on from our introduction, and the reason why we chose this proposed title was because that the face recognition is crucial for everyday interaction, such as communication and other menial activities that let us lead our daily and social lives. Given the advancement of technology and the growing use of computers in daily life, it is imperative to design systems that can precisely recognize and detect human faces. To achieve the intended goals, we aim to offer a technique that can successfully detect and recognize faces. Adabus is a use to cascade a lot of differentiating traits, which results in a powerful classifier that can correctly categorize photos. This ultimately results in precise facial recognition. Finally, can be precise facial detection is about the outcome. Then, for further processing, the well-known local binary patterns known as LBP are used to do the research topic. The original LBP operator recognizes the pixel of an image by thresholding the polygon area around each pixel with its center pixel value and using the result as a binary value. Then histograms from each subregion are collected and concatenated to produce a single spatially enhanced feature histogram. Using the feature histogram as one of the key distinguishing factors, the SVM classifier finds the target image. As a result, the approach satisfies our demand to detect and can able to analyze the face photographs for several applications. So moving on for our next page is about our statement of the problem. And as you can see here that the facial recognition is very challenging to identify a specific individual within a group of images. The many variables that might lead to variations into images of the same face make it more challenging to accurately identify faces. To correctly identify the target images, the following problems must be resolved on these three problems that can be solved. So number one is that it changes in facial expression, age, and appearance, such as with or without spectacles, and so on. The second problem was about its scale and the changes in the scale, position, and in plane of the acquisition geometry, the face's rotation. Lastly, the third part is the changes in imaging, including the variance in lighting and cameras. Considering all these variables, we may evaluate the distinguishing qualities that make one individual stand out from another, producing a feature vector for each sample. Following the processing, these feature vectors from the dataset are compared to the test or target images. The label that has the most striking likeness is the one that is meant to be applied to the image in issue. Moving on to the third page is our objectives. So our objective is to develop a system that can instantly locate and recognize faces in digital images derived from video input. The contour of the face and the area surrounding the eyes are two defining elements of the face that are essential for identification and recognition. The following list summarizes the primary goals of the project of these three objectives that we came up. The first objective is to develop a face recognition system that can quickly recognize its face in crowded environments to reduce the influence of extraneous components as much as possible in the real-time context. The second objective is that the next step is to provide our system with enough images after the face recognition phase is finished. Histograms must be obtained and concatenated for such subarea in an image for being used to create a feature vector for each image using a local binary patterns, or you can call it short LBP. Lastly, we want to evaluate different or recognition algorithms. Each of them can balance such as accuracy and rapidity. And that's our three goals to improve in this project proposal. The next page was about the solution. Our solution here is that numerous sectors might benefit from face recognitions, and according to these results of our analysis, the proposition may be described as follows, such as the multi-class classifier accuracy may be enhanced, which will increase its accuracy. Other traditional approaches may be employed and compared to obtain findings for a large database with higher accuracy, and the second part for this to prove our solution was to improve the accuracy. We may apply it to the range of areas including the improved surveillance 24/7 in our campus. The next step is about methodology. So our methods are not about what we working on is that the facial recognition system for the campus is that it's a system which works by identifying and measuring the facial features of anyone that will enter campuses around grounds. Before a person can use the system, they will have to be a student, a professor, a worker of the school, and will have to undergo a few steps for the system to recognize their faces. Once those steps are accomplished, the facial recognition system can able to detect someone's face before entering the school premises. Lastly, this is our project cost, and as you can see here, it only costs us about 33,500 pesos for facial recognition system, and our units that we are about to install was only at the school entrance for us to recognize every students and professors, even workers, for before they come in. If they don't even recognize their facial recognition or not from here, they're not allowed in entry. So as I was saying, the quantity of this was about 4 cameras, and the subtotal of those was about 94,000 pesos in grand total cost. And that's it. That's our presentation for our group proposal of about facial detection system that we're about to implement in our De La Salle University in Das Marinas around in our campus. Thank you and have a nice day.